All right, a quick lesson on adding velocities. When you add a velocity, what you're doing is you have to take, velocity is about when things go in a particular direction, and you need to figure out your reference point. So let's take a look for a second at our guy who's walking on a truck. If the truck's not moving, then it's going the same speed as our reference point cactus. So then the only movement is our guy going on the truck. So if our guy goes 3 meters per second, then you add 0 meters per second plus 3 meters per second, and it's in this direction. And we're going to call this east. So our guy's going 3 meters per second east compared to the ground. But what if he's Indiana Jones? If the car is moving, let's say our truck is traveling. If the truck is traveling at 30 meters per second compared to the cactus, and our guy is going from the back of the truck to the front of the truck at the same time while the truck's moving at 3 meters per second, then they're both going in the same direction and you add them. So it's 33 meters per second forward, in this case, east. But what if our guy is going backwards while the truck's going forwards? Okay, so if the truck's going forward at 30 meters per second, and the guy's going this direction, and the guy's going 3 meters per second the opposite direction, is he going faster or slower than he was before compared to the ground? In this case, it's a subtraction problem. So it'd be 30 minus the 3. So the guy's speed is a net speed or a total velocity of 27 meters per second. The thing is with total velocity is that you're looking at this number here is the guy's speed compared to the truck, and what you're trying to find is the guy's speed compared to the cactus. So you want to make sure that you're trying to figure out what's moving in what direction. If both things are moving in the same direction, then you add them together because the cactus isn't going to move. If both things are moving in opposite directions, then you subtract them. And if one thing isn't moving at all, then there's no math operation. Now this is a pretty simplistic version. It's a little bit more complicated if you're thinking about a boat that's trying to cross a river. If the boat is trying to go straight across the river, but the river, and let's say it's trying to go straight across the river at 3 meters per second. Is the boat going to be right here if all it goes is forward? What about the fact that the river is moving too? If the river is moving at 3 meters per second, then you have to calculate where the boat's going to end up. And you have to try to put these two together. The math to put those two together requires trigonometry, which none of you have. So that is why we're not adding velocities that are at angles. But you can still kind of figure it out. If the boat's going this way, if the boat's trying to go this way, and the water's going this way, then the result is it's going to go that way. Because it has to combine the two directions. On our truck example, when you're trying to combine something going this way and something going that way, you just have to subtract them. If you're trying to combine two things going the same direction, all you have to do is add.